for the machine drawing components. So first we need to discuss about the drawing sheet. So what is the importance of this drawing sheet? Right now that we have the software, but earlier days, and this people are able to make all the machine components of this drawing sheet, right? So generally we follow this A0 sheet according to the ISO series A. Generally we follow this ISO series A, and the dimensions of this drawing sheet you can note down. That is 841 and 1189 mm. So generally we follow this sheet A0 sheet, right, for the making the machine drawing component or assembly of the drawing sheet. So apart from this, just you can see it, the ratio of this drawing sheet is just we are dividing the half of the A0 to A1, A2, A1 to A2, and A2 to A3, and A3 to A4. Just you are giving the folding of this drawing sheet. Suppose if you have this any type of sheet is there, right? Just you can fold it half or part of the drawing sheet. So if A0 size is 841 multiply 1189, 1189 mm. So just you can give the folding of the drawing sheet. First you need to remember the one drawing sheet only. So this page is visible to everyone, I think.
Yes, sir.
Yes, sir.
Yeah. So just you can do the folding of this page, right? Then we have the size of A1. That is A594 multiply 841. Again, you can do the folding. So you can just divide the half part. So this you fold it to 2. You can follow this. So you will have the size of the A2. So like this way, this is the folding of the drawing sheet to show you to understand. No need to remember all the dimensions of the drawing sheet. Generally, we use it for the this A0 sheet, right? For the drawing purpose, and A4 sheet for generally you can do the printing, right? And if you have the large diagram or something, then you can use the A3 also. So only two diagram drawing sheet you can use for the drawing purpose. So you must remember the size of the drawing sheet, that is the A0 and this A0 and A4. So we generally use the A4 for the printing purpose. So I'm just showing you the A4 sheet. The dimension is 210 multiplied 297. So according to the International Standard of Organizations, we follow the A series. There is another series for B. So B is the depending upon the requirement you can choose or company may propose. But general principle is this is the dimensions for the drawing sheet. So this is the drawing sheet format. Okay. This is the drawing sheet format, you can use it. So main thing is the just you can either use it the x and y equal to 1, right? Or you can follow this x that is the raised to this y equal to 1 raised to root 2. This is the drawing number. So 1 A0 seed component size is that is the 1 meter square, completely 1 meter square size, right? And you can divide this dimensions either you can follow this x raised to 1 equal to x raised to y equal to 1 raised to root 2, or xy equal to 1, that is the 1 meter complete size. If you multiply this 841 multiply this 1 and 89, then dimension will be the 1. So that is the 1 meter is square. That is the size of this A0 sheet. So you need to remember only one sheet dimensions, right? And you can do the division of this by 1 to 2, then you will get the another sheet size. So already you use it the in the this drawing sheet. We have to make the title block. So what are the information we can use in the title block? Either you can use the horizontal sheet and vertical sheet. In both the cases, you can use it, and you can see what are the informations we must provide in the title block. So this is the location of title block, and information is that drawn by, then checked by, and approved by. Right, you can mention the date, then the material. What are the material you can use it? For example, if you want any of the machine component, you can use it for mild steel. So you can write down the mild steel or in the metal symbols and tolerances. So already I told you in the first class, right? So why we are giving the tolerance means there are certain limit we have to add in this, either this on the uh, upper side or lower side. For example, one dimension is 1, and plus minus you can provide some 0.1 mm or 0.1 1 mm in the this negative side and positive side. So you can give the tolerances on the machine component. So generally in the casting we need to do the this must provide these types of tolerances, right, so that uh, we can manufacture the component in the machine shop. Otherwise it will be difficult to get the exact shape and size, right, on the casting parts. Another is the finish symbol. If you want to do the machining surface roughness, anything you want to mention, right, the roughness value you want to mention, then you can note down the 0.5 in the micrometer or what, depending upon the recommendation you can use it, right. So title of the drawing is important, and legal honor, then the projections. So this is the projection symbol is the first angle, third angle. This is symbol of first angle or third angle. You see,
Yes, sir.
this is the symbol of first angle or third angle. Anyone?
Sir, first angle.
Yeah, this is the
First
symbol
angle.
of first angle, but this is the first angle projections. So in India, according to the this Bureau of Indian Standard, just generally we follow the first angle symbol, right? So this first angle projections we generally able to use it, right? So this is the first angle symbol. This is the first term of cone, right? So you can see this from this side, and you can able to draw in the projections on the vertical plane, right? So this is the first row of cone, the first symbol and second symbol. So first arrow, this circle and second circle. So this is the first angle projections. You must follow the symbols. You must remember this, right? In the first angle case, right, the symbol, this is the viewer. You can see the first row of cone from this first side, and this you can draw the circles, and the second last side, right? So you can draw the bigger one. This is the first angle projections, and just you can do the opposite one, that is the uh, have this model. So in that case we have the third angle symbols, right? So I think you have already studied this first angle and third projections. So either you can, generally we can follow the first angle projections. So you need to must draw, either you have drawn this drawing in the first angle or third angle projections. What is the purpose of this scale? So generally we prefer a scale is 1:1, that is the full size scale. So in the full size scale, the option is to, you can show the exact picture, right, with the true shape and size. So generally we must follow the full scale. But the problem is if you have the full scale, it is okay. If they are bigger machine size, then in that case we have to reduce the scales, right? For example, the lace machines or any of the crane or any of the rail, right? In that case, you have to reduce the size. Or there is another option we have, either you can enlarge the size. So sometimes we have to reduce, so sometimes we have the option to this enlarge the object. So in that case, you have to put the scale size. So either you have to follow this 1:1 or 1:2 or 2:1, anything you need to mention. Then the identification number, right? So every drawing must have the number, right? So you can, based upon this number, you can put it. So how many drawings you are able to make it. So then the dimensions of this title block, you know that it 170 mm by the 65 mm. So this dimension block, this is the location of the block. Either you did it in the vertical side or horizontal side, anything you can put it, but this dimensions must be provided in the drawing sheet. So you know that about the drawing sheet dimensions, right? Then the title block locations, then the this information provided in the drawing sheet, right? Then the this ISO dimension series, that is according to the ISO series A. Then we're talking about this drawing sheet layout. So you know the drawing sheet now. This okay. This is the first we need to scale this full size. You know already 1:1 in the full size 1:1 option. We have the option is full size 1:1, and full size we have the option 1:1, and this enlarged size, enlarged scale, you can see either we must follow the 1, 2, and 5. So this is the scale ratio. Either you follow 1, right, or 1 means 1 to the full size, right, then 1 or 2 and 5 if you want to do the enlarging the scale, or you can do the reducing 1:2 and 1:5 and 1:10. So this is the rule you have to do the this reducing scales or enlarging scales either in the 1 raised to this 1 raised to 2 or 1 raised to 5 or 1 raised to 10. And if you want to the enlarging scale, then that is the 5 raised to 1, 2 raised to 1, and that is the 1 raised to 1, that is the full scale. So we will not write here 1 raised to 1. So this is the 1 raised to 1. So then multiple of this 1, 2, and 5 you can use it. So you can for another, if you want to reduce or enlarge, that is you can write 500 raised to 1, then the 200 raised to 1. So like this way, multiple of this 10 you can increase or you can reduce the scales, right? So generally you must this remember that is in the scales we must follow the 1, 2, and 5. So this minimum width, that is the, if you have the drawing sheet, right? So in that case, we have to do the some border and framing. So why we need to do this bordering and framing requirement in drawing sheet? The main purpose is during this manufacturing process, we are not able to make it the accurate sheet. So in that case, you need to do the border and framing on the drawing sheet, right? So there is a minimum width of this border and framing. You can see that is 20 for A0 and A1 sheet, right? You already remember the sheet size, 0.41 by 1189, and the 10 for the A2, A3, and A4 sheet. If you want to do the drawing on the 10 of this A4 sheet, in that case, we have to follow the 10 of the this trimming mark, or here is the 20 of the trimming marks. That is the size of A0 and A1. So you know this is a trimming mark, right? Then this is the edge, you can see that is a grid reference border, then the title block, right, centering mark, this metric reference graduation, then the drawing space, orientation mark, and frame. So why we need to do this grid reference border? The main thing is the you need to have the this marking. So for example, if you want to draw something and this part, right, and if you want to do the locations of this this drawing, suppose you have to make some bill of material or any of the small components of washer, simple you can draw this washer in this part. So if you want to distinguish these types of washer here, to just you can locate here, we have to make this D and 1. So position of this D1 is for washer. So in the Indian map or any of this bigger map, right? In that case, just you need to do the location. So in that case, for distinguishing this location, you have that grid reference border. So either you can divide this 10 circle. For example, you see the complete dimension is 10 then you can make it the grid of 1 right? Or if you want to decrease or reduce, you can do. But you must follow some grid lines, right, for the referencing purpose. So you can put 1, 2, 3, 4, anything you can mark it. Under Roman symbols, you need to mark it. So in the horizontal directions, we have to put in the 1, 1, 2, 3, 4, and here we have to follow the alphabet or ABCD, right? So that both the combination of this alphabet and this numerals, you can able to distinguish the drawing position within the drawing sheet, right? So like this way, this is the metric reference position is there. Here is the centering mark. So you, with the help of the centering mark, you are able to distinguish this. Yeah, this is the center of the machine part. So you have to check the dimensions, or you have to figure dimensions. You have to find out dimensions from the this part, upside and downside. This is the orientation mark. So you need to understand. So if you have this Indian map, just you can see it, right? You can check it. That is the in the previous drawing, or nowadays also we are using these types of orientation mark to know about this the centering of the drawing sheet. So we need to start the center. We need to check the do the this dimensions from the this point center mark, right? So this thing you must understand in the drawing sheet, right? So next is the types of lines and their applications. So types of lines, why we need to do the this different types of line on the drawing, so that you can distinguish the different applications. So you can see the types of line and so types of line and this and their applications. You can see the lines, that is the lines, that is the continuous thick lines. So you will able to draw a diagram, right? A1 visible outlines. Then the continuous thin line, straight or curve, right? B1 for imaginary lines intersection, B2 for dimensions line, B3 for projections line, B4 for leaders line, B5 for hatching lines, B6 outlines of revolved section in plane, right, in place, and B7 is the short center lines. So I have the one example. You can see if you have the machine drawing book, just you can check it, right? The symbols. Other is the C continuous thin line freehand. You can draw it, right? If you have the this limits of partial or interpret view and sections if the limit is not in gigantic, right? Then the continuous thin straight with zigzag, that is the D1 line. So there is symbols, and this dash thick means hidden outlines E1. Then the chain thin, that is the bigger symbol. Then that's, I think, this line types you have already studied in the this engineering drawing courses, right? G1 for center lines, G2 for line of symmetry, and G3 for trajectory. Then the chain thin thick at the end and changes of directions, right? So cutting planes. If you want to show the cutting planes any of the object, in that case you are going to put it some this bold line and the dash line in between the this bigger line, right? Then the chain thick line, so indication of lines or surface to which a special requirement applies, right? And the chain thin and double dash, so K1, that is the outlines of adjacent part, alternative and extreme position of mobile parts, and the central lines. So this ratio, you can see the ratio of the thick line to thin line should not be less than 2:1, right? If it is less, this lesser than the ratio of this one, then you will not able to distinguish it. The thickness of the lines may be 0.8 mm, 0.25, 0.235, 5.7, 1, sorry, this is 1.4 and the 2 mm, right? So these types of lines you can use it generally depending upon the drawing sheet, right, and size. And this the space between the two parallel lines including the hatching. So during this hatching or sectioning you want to do it, in that case you have to follow the dimensions of the line is 0.7 mm, right? So now you can see the applications of the lines. So if you remember this, that is the application of lines, then you can see this is the machine component, that is the main machine component. So this is the main machine component. You can see the object, some here, some table surface is there. This is the line, right? So this is the outer line. We have to make it for the drawing, right? Here, this is the meaning of this zigzag, means we are showing this dimensions is not the exact one. This is not the only exact dimensions of this 100 or 50 or something, but this dimensions may be larger than the as well in the this drawing. So this is the mark of this zigzag line you have to show. Means drawing is size increase. So like this way you can do. So those if you do the hatching, right, the section dimension between the one line and other line is dimension is 0.7 mm. Generally we follow for the hatching applications, right? So some of the zigzag line is there. So depending on this line, then the center lines you can mark it, right? Here also you can see these dimensions. Tenth line we are using it for this enlarged applications. So there is a big part, right? In the casting big part, in that case also we have able to represent it. So we are able to represent it the different line dimensions. So you can see the hidden line. This position is here now, right? This is actual positions of this object, and we are putting the showing this part. Suppose this is the piston part, so piston will move this side to this side. So just in that case you can put the hidden line within into the center lines, and in hidden lines they are showing, yeah, this part is movable and it will come under the second stage at this position, or in the third position so you can also draw. So this is the part showing this thickness of the part, right? Width and thickness of the parts you can use it. And if you want to cut it this part, then you are able to make it the cutting plans in the terms of lines, right? Or any of the symbols is there, then in that case you can use it. So this is the shape and circular of the part. So sometimes we need to distinguish the internal part of the object with the help of this cutting the line, this cutting the this object with the help of cutting plane, right? And then you need to visualize the object. So this is the types of line you can use it. Here also you can see the distinguishing of this cutting plane. This part they are exact location is this, but they cut it and they are trying to show it in. the internal part. So main part, this main purpose of this cutting line, a cutting plane, is to visualize the internal part of the object. So if you want to do the visualizing of this internal part, in that case you can use the cutting plane, and you can able to draw these types of lines. This is the correct cutting plane lines, right? And this part, two parts showing the cutting planes. Just you can cut it the part, cut it the object, and you are able to make it. So you can able to you can visualize the internal objects. So this will go through these different types of lines, right? And just you can see the different types of the lines, right? And you can use it for the this machine drawing applications in the drawing sheet. So another is the order of priority of coinciding lines, right? So this visible outlines and edge, right? So continuous types of line A we can use it. Then hidden lines, outlines, cutting planes, center lines, and line of symmetry, and central lines and projections lines. So where we can use it, this type of order of priority in concerning lines, when these two lines are meeting at a point. Suppose if here is the three lines. One is the center lines you are marking, or this circle, center circle is there. Another is another line. So in that case, you have to follow the order of priority of coinciding lines. When these two lines are coinciding, what the rule for this? So in that case, this rule is the visible outline and edge. So this outline must be visible outline and edge. So you have to follow the type A line. Then the hidden outlines edge. The second, the hidden part is there. Then you have to follow the ear F line. So some of the another third is the cutting plane. If you want to show these types of cutting plane, in that case you have to use the type H line. Center lines and line of symmetry type G. So central lines type K, and projections line type P. So this is the order of priority. So in the next, you can see the individual lines. So what is the rule for this individual lines? So instructions in this correct line and the incorrect line. So you can check it here. Correct line and incorrect line. So you can see you have the continuous line, right, and you are connecting with the dash line. So this is a method of making this dash line. This is not gap should not be between this continuous thick line and dash line. So this is the incorrect method. Begin with the dash, not with a space. So space not provided on the line. So in the previous diagram, you can see that is the space is not provided in the line. Just they are starting the line with the thin line and dash line with the help of this dash line by meeting the point at the continuous thick line. Dashes intersect without a gap between them. Dashes intersect without a gap between them. So if you have the dashes, then you have to make it the line this way, right? Having the dashes, then in that case you have to make the gap. In that case, you should not start from here, because this is the hidden line. We are showing the hidden part of the object. So if you have, so dashes intersect without a gap between them, right? Here is the gap. First one, this is the incorrect one, and if there is in the dash line there is already space, right? In that case, we have to follow some space. So this is the correct method. Dashes, three dashes, three dashes meet at the intersection point. So all the point is meeting at a this all this dashes line are meeting at a point, right? So then all the lines must be intersect at a point. So here is a space. So this is the incorrect method. If the dash is meeting at the intersection point, then all the point must be all the line must be at the center point. As a continuation of a visual lines and arc begin with a space. So you can see as continuous this continuation of the visual line arc begin with a space. So if you want to extend further, right, in that case you have to make some space. Means this part is different, part number one, and this part is showing two mobile of the object. So this is the part number two. Or any of the symmetry, if you want to show it, in that case you have to make it the hidden line. So this is the real object. So you must follow some certain gap between the real object and the hidden line parts. So here is you can see that is a not this making the space. So it means if you want to do the dimensioning, so you have to do the dimensioning from this part to this part. So this is the dimension, but this is the incorrect dimension, right? This is not the object. So this is the we need to show the hidden line. So you must follow this type. Exact dimensions of the line is this, right? So as a continuation of visible line or arc began with a space, right? So invisible arc began with a dash. Here also we have the individual arc, right? In that case you need to start from this point and the this point, so that in that case you are able to do the marking. So you can find out, you can note down the radius is how much, 5 mm, so you can put it the dimension is 5 mm, right? So this is not the case, so you have to mark it for the this space should not be there from this line to the dash line. So individual marks begin with a dash. Small arcs may be made solid. So small arc means if you have the dimensions of, generally we follow the small curvature of any object. In that case, if you follow, the some of the chambering dimensions must be follow the 3 mm, 2 mm, or less than the 5 mm. Generally we follow the less than the 5 mm. So in that case, if you want to do the chambering, then in that case that we have to follow the complete line without this dash line. We need not to draw the dash line, but we have the solid line, complete solid line showing the radius, or you can note down radius is 3 mm. If you have, so you will able to this on the machine drawing part. In that case also you can see, right? So these two arcs meeting at the point of tangency. So tangency means that the two circles are meeting at a point. So if there is tangent line is there, right, in that case you have to mark it the line, right, not putting the gap. So just you can meeting at the point, meeting at the line, right? So that means two arcs are meeting at the tangent. Just you are able to show it. So you can know the radius, right? This must meeting at the certain line. Two arcs meet at the point of tangency. Some axis line, this is the part for axis line. This is all about the lines and hidden lines, and this outer periphery, sometimes some circles you can use it for drawing purpose. But here is the time this talking about the axis line start and ends with the dash line. This is the axis line. This is the axis line, right? This is axis line. This is not the method. This is incorrect method. We are not making the dash in between. This is the incorrect one. This is the correct one. We are not putting the dash in between. So there is a one, two, and third part. There is only one and two part, right? So axis line start and ends with a longer dash. Then the two axes intersect with longer dashes. Here you can see the distinguish, and there is, if the two axes are meeting at this point, right, then the you have to show this types of line means two axes are meeting at the point. Like this way you have to make it. Two axes intersect and with a longer dash. Then the another one, this the line meeting at this point. Here is also you have to make it the longer line, longer dash, right? This is not like this space you have to provide on this. This is the incorrect method. Axis extend the boundary with longer dash. So extend with the longer dash means if you want to start the drawing, you can see always you follow, you have to extend the axis line on the both the in. Here you can see line is not extended. So you can see here in this diagram we have extend the line. Here we also extend the line. So the axis line whenever we can draw, then the line must be extended apart from the object. Here also you can see line must be extended apart from the this object. Exactly we are not able to make it in the case of axis line. So this is the axis extend the boundary with longer dash. So we have to increase the axis and increase the line size. So any doubt in this invisible lines, this drawing sheet part, title block informations, where you can use the different types of line and their applications and the individual lines. So any doubt in this? So termination of the next is the termination of leader lines. So termination of leader lines means now you want to make it any of the object, any of the drawing, right, in the drawing sheet. So you must follow the this. So you must follow the this representing method. So this is a leader line. This is called a leader line, and just you can show it. So this is a circle of dimension or any other this diameter, and then just you can note down if you want to represent the diameter of 10, or you can this welding symbol or any other surface symbol. If you want to represent, you can represent it. What are the different types of this welding? If you want to do subjoining of the parts, you do either you can do the joining or welding. So this is a welding symbol, this is a fillet weld symbol. So either you can do, or if you want, then you can note down the what are the different types of process we can follow it. So this is the one of the welding process. So like this is the method of leader line representation, right? So either you can, this is the complete object, you can mark it with the help of line, or you can showing with the help of this leader lines with the help of arrow, right? Or third one is the, you can note down the dimensions. So in the previous diagram also we have the dimensions, then you can put out, or if you can extend the leader lines, you can note down, or simply we can write the dimensions here also of 100 mm, or you can note down the dimensions of 100, then one sentence you can, right? That is the all dimensions are in mm, right? Or any of the process you want to distinguish. So this is a method of this leader line representation of the object. So this line, the rules must follow, right? In the case of this machine drawing part or in the assembly, there is multiple lines are coinciding. So in that case, if the multiple lines are coinciding, in that case, then you can increase the this. You can use it for this leader line, extension of the leader line, and you can use it for this line. If there is no space providing on this machine drawing parts, then you can extend the line and you can note down the dimensions, or you can note down the any of the features, right? So dimensioning of letters. So dimensioning of letters, I think you have already studied in the first year courses, we have already drawn, right? So we will not discuss all types of this inverted this dimensions at a certain angle, right? Or some exact vertical this lettering, right? So you know already this, so we will not discuss about this. So hatching of the sections. So hatching, why this hatching is required in this of the machine component? So that the main purpose of this hatching is to show the internal part of the object, or some of the part is solid, some of the part is hollow. In that case, you can have the options to do the representations. So preferred hatching, you can see the preferred hatching, generally we follow it. So preferred hatching, generally we follow it, right? Either you can do the horizontal line, any of the object is there, you can do the hatching either horizontal line, right, or vertical lines, right, or at a certain angle. So depending upon the drawing or depending upon the requirement, so we need to follow it. So why you have changing the dimensions? Means one part, if you can show it within the horizontal lines, it means all the parts, all the components, all the parts are same. So hatching dimensions, you must remember that is that dimension is 0.7 mm line, 0.7 mm, and the line thickness you must follow. Generally, we follow the 0.7 or 1 mm, right, or 0.5 mm when thickness, line thickness, right? So one part of this hatching is showing the one part. So see here, this line types is at an angle, but all the lines are same, means showing the, this is the one complete object, right? Here you can see in the next diagram we have the two different objects. Here is the line shape is another one, and here is the line is the crossing a different one. So we have the two objects. So hatching dimension is different, right? As this is another third one. You can see hatching this hatching direction is changed, right? This is third one. Here also you can see the dimension, this hatching directions. Here is the one part, and another is the other object is the second part. So hatching part is different. So either the part is same, in that case you need to do the hatching in the same directions, right, and follow the angle. Either or you can do the horizontal or verticals, right, or you can do the hatching in the same part, or in the, just you can change the hatching directions. So here you can see the hatching direction is quickly changed here, or opposite one. So preferred, either you can use it for the horizontal line or vertical line or certain angle at 45 degree, right? So you can use it for the hatching. This is called as the prefer hatching. So if you have the multiple object parts, so in that case, either you can change it the hatching directions, right? Or you can change the this. You should not change the this distance between the line, one line to another line, but you can change the direction only. So hatching of adjacent component means that is a part that is going to mix, that is going to join it, right? So in that case, if you have suppose a pipe, and this pipe you want to do the reducing the size of the pipe. So in that case, there is one clamp, and another one is the pipe. So if you want to make it the reducing part of the object, generally we have to follow these types of reducing object in the household applications, right? So if you want to do, so this is the one is the clamp. So one part is the clamp, and another part, this is the object, another part into extend the pipe. So in that case, to change the hatching, so that you can distinguish this is the hatching part and this is the object, right? So see, here is the clamp. This, you can see these types of line here, the direction and these directions are both are same, and here these directions of this pipe and this direction of the pipe are same. Means it represents that this hatching directions is same, this hatching is same. So that is the one component, and this hatching is same. So that's representing the other component. So this is the another part number 2, and here is the part number 1. So this is the purpose of hatching of adjacent component. So here is the rivet pin, you can use it. This is the pin. This is the pin, and this is the washer. You can use it, or nut, and this bolt or ring, you have to use it, right? So this hatching dimension same, means showing the one part. Pin, we have not do the hatching. This is a rule. So solid object should not be hatched. So this is the pin in terms of solid object. This is not should not be hatched. So pin, rib part, any of the solid part, this pipe, this bolt, right? You can see this bolt should not be hatched. So as per the rule, bolt should not be hatched. So this is the solid, but this is the nut, and this is the bolt, and this is the bolt head. This is the bolt head, bolt head. Bolt, and here is the nut. Here also you can see there is a pin part, right? So joining up these two pipes or two solid bars, right? So here you have to use the collar. Here is the shaft. If you want to join the two shaft, here is the pin. This is the assembly. So in the this shaft is solid, so we should not hatch this shaft. We should not have this. But here is a collar, so you have to have the collar, just showing that this part is circular and showing the same direction of the hatching. Here is showing the shaft. Here is the pin. Another assembly you can see, that is the rivet joining. Generally we use it for this joining of the seat bucket. In this example, rivet, this in the bridges, rivet. So this is a rivet, and this is the one metal plate, and this is the another metal plate. So you can see this hatching directions. Here hatching direction is different. Here hatching direction different. Hatching direction, this part and this part is same. This part and this part is same. But in the both part plate, or you can say one plate and two plate, the hatching of these two plate are totally different. Means showing the one part and another part. Here and it has the sectioning along the two parallel planes. If you want to do the sectioning of two parallel planes, or you want to cut it, the visualize the internal part, this line being the visualizing of this internal part. So with the help of this cutting plane, we are able to visualize the internal part. So you can cut it. So you can cut it, and you can see the top surface. This is the cutting plane. If you cut it the object, so this visualize this steps of this line, you are able to visualize the internal object. Another is a hatching interpret for dimensions. So there are two dimensions, inside is different, here is different. So in that case, you have to put the dimensions. Either you can, otherwise you can cross the line. So if you cross the line, then the numerical value will be not visible, right? So in that case, you can mark the space. This is also one of the method. Other method I told you, either you can increase this line dimensions, you cannot on the this dimensions, right? Or if you want to don't want to this represent the dimensions here, then you can extend. You should with the help of some certain gap, right? First you mark the some gap and then you can put the dimensions, exact dimensions. So hatching interpret for dimensioning. So cutting planes, only with the help of this cutting plane you are able to visualize it in the internal part. Any of the part you can object it and cut it, and you can able to see it. For example, this is the this slope thumb, you can see it, and just you want to cut it, so you can just cut it from the front side, right? And you want to visualize the mark, so with the help of this cutting plane you can visualize it. So if you can cut it at the center, this object is clear to everyone, I think. Object is clear.
Yes, sir.
Yeah,
Yes, sir.
so you just you can cut it the vertical directions, right? Or this is horizontal directions, right? And you are able to do the drawing. So in that case this is just like a pillar, so this is just like a pillar, right? So just if you want to cut it this part, so what is the front face in that case? So you you will able to visualize the same part, but this is a circular one, then you have to make it a circular. This type of shape you will object, this type of object you will observe. So this is the method, visualize the internal part. So just you can use it the cutting plane. So this is the types of method you can use it the cutting plane from the x-axis here, x-axis, right? X-axis representing this x-axis, and just this is a method to visualize the internal part. Same here, we are able to drawing it here. This is the application of cutting plane. Just you can cut the object and you can visualize the internal part of the object. So just you can cut it from this circular part, right? And you will see after this cutting the by the help of this cutting plane, that is circular. If there is a hollow impression, then you put a hollow impression. If there is something different shape is there, then you need to draw it. So this is the method of cutting plane. So in some for the pipe applications, you can see another example for this piping applications. So there are different types of pipe joint is there. In that case also you can use it for the cutting. If you can cut it, then you can visualize the dimensions of the internal part. In that case also you can use it. Similarly for the next diagram, right? And here also this is the shaft, right? Here is the flywheel. Here is the flywheel, right? And here this part is key. Here is the keyhole, right? And here is the shaft. This part is joined to this element, right? Shaft surface, or you can